Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics 2024 exam. In this video, we discuss the solution of a problem from the section Real Analysis, and it is from the subsection Functions of one real variable. This is a multiple choice question for 2 marks, and the serial number of the question is 24. Further, this question is suitable for all these examinations. This question is most suitable for JL, DL, TG set and AP set examinations. Right. The given question is: consider the following 2 statements. Statement P: there exist functions f from R to R and g from R to R such that f is continuous at x is equal to 1 and g is discontinuous at x is equal to 1, but g compose f is continuous at x is equal to 1. So we have 2 functions f and g from R to R such that f is continuous at x is equal to 1 and g is discontinuous at x is equal to 1, but g compose f is continuous at x is equal to 1. Is this statement P true? Statement Q: there exist functions f R to R, g R to R such that both f and g are discontinuous at x is equal to 1, but g compose f is continuous at x is equal to 1. Which one of the following holds good? We are given 4 options, and option A, both P and Q are true. Option B, both P and Q are false. Option C, P is true but Q is false. Option D, P is false but Q is true. Right. Let's now discuss the solution of the problem in detail. We consider the statement P. The statement P says there exist functions f and g both from R to R such that f is continuous at x is equal to 1 and g is continuous at x is equal to 1, but g compose f is continuous at x is equal to 1. Right. We give an example. Let f R to R, g R to R be functions defined by f of x is equal to 0 for all x belongs to R. It's a 0 function. G of x is equal to 1 when x is equal to 1 at that point, and when x not equal to 1 it is 0. Right. Clearly, f is continuous everywhere because it is a constant function, and we know every constant function is continuous everywhere, and in particular it is continuous at x is equal to 1. Because it is continuous everywhere, obviously it is continuous at x is equal to 1. And for x not equal to 1, look at g of x. When x not equal to 1, g of x is equal to 0. As x approaches 1, x not equal to 1, as x approaches 1, gx approaches 0. Therefore, limit extends to 1 of g of x is equal to 0, which is not equal to g of 1 because g of 1 is 1. Thus, G is discontinuous at x is equal to 1. Now, let's see what is G compose f. G compose f of x is equal to G of f of x. G of f of x. But f of x is a constant function which sends every element of R to 0. So, G of 0, that's equal to 0. G of 0 is 0 because 0 not equal to 1. G of 0 is 0. And this is true for all x belongs to R. This is true for all x belongs to R. And G compose f is a constant function, it's a 0 function, and every constant function is continuous everywhere. Therefore, G compose f is continuous at x is equal to 1. This implies G compose f is continuous everywhere as it is a constant function. Thus, G compose f is continuous at x is equal to 1. So, option P is true. The statement P is true. Right. Let's go to the next slide for the discussion of the statement Q. The statement Q, there exists functions f and g both from R to R such that both these functions f and g are discontinuous at x is equal to 1, but G compose f is continuous at x is equal to 1. Right. For this, we consider f and g from R to R are functions defined by f of x is equal to 2 when x is equal to 1 and f of x is equal to 3 when x not equal to 1. G of x is equal to 1 when x is equal to 1 and g of x is equal to 0 when x not equal to 1. By the very definition, it is very clear that both the functions f is discontinuous at x is equal to 1. Obviously, there is a jump. And g is a discontinuous at x is equal to 1. There is a jump. So, these are, both of them are jump discontinuities. Right, at x is equal to 1. Now, consider, for x not equal to 1, consider G compose f. G compose f of x when x not equal to 1, that is G of f of x. When x not equal to 1, f of x is, when x not equal to 1, f of x is 3. So, G of 3. G of 3 is 0 because 3 not equal to 1. So, when x not equal to 1, it sends every element, G compose f sends every element x not equal to 1 to 0. What happens when x is equal to 1? G compose f of x is equal to G of f of x. When x is equal to 1, f of x is 2. And G of 2 is 0 because 2 not equal to 1. Agreed. That means G compose f of x is 0 for all x belongs to R. Thus, it is a constant function. Therefore, it is a constant function. It's continuous everywhere. Therefore, G compose f is continuous at x is equal to 1. Thus, the statement Q is also true. So, thus we have seen that both the statements P and Q are true. Therefore, the answer to this question is option A, which says both P and Q are true. That is the detailed discussion of the solution of this problem. Right. And it is a very simple and straightforward question. And the question is framed basing on the concept of continuity and the continuity of the composite functions. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video. Please like my videos and share them with your friends and colleagues. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I'll meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.